Alright, so here's your practice final, a video version, so you can go back and do recording, or rewind, and things like that. A manufacturer sells car batteries for $150 each. This will give us our revenue when X is the number of batteries, which looks like 150 times X. The company's fixed costs and their marginal costs will give us our cost function, marginal being the slope, 55x, and the fixed cost of $45,000. Together, we know that profit is revenue minus cost, so it's 150x minus all of the cost function, so I use parentheses, minus 55x plus my 45,000. My pen's a little slow. And then simplify this, people. It's going to be easier for you later. So 150x minus 55x is 95x. And distribute the negative to get a negative 45,000. Don't pay attention to that double zero. I catch it here in a minute. So how many batteries must be sold to break even? Well, break even is when revenue equals cost or when profit equals 0. So I set 0 equals 95x. See, I noticed that extra 0 on the profit function there when I went back to it. 95x minus $45,000. In order to solve for x, we're going to add 45,000 to both sides. So 45,000 equals 95x. To get x by itself, now we'll divide both sides by 95. 45,000 divided by 95 is equal to, take a minute, use a calculator if you need to, 473.6 and some other digits, which will give us an answer of 474 batteries rounded to the nearest battery. Okay, everybody needs to know how to evaluate a function if you're going to pass this class. So what I'm going to do is I'm going to use a skeleton form. Our function is 2x squared minus 3x plus 1, but I think of that as 2 times something squared minus 3 times something plus 1. For this first problem, instead of the something, instead of the x filling in the parentheses, I put in a negative 3 because that's what it's asking me for. F evaluated at negative 3. I use my order of operations. Negative 3 squared is 9. So I'll have 2 times 9. And then a negative 3 times a negative 3 is a positive 9. Don't forget your plus 1. 18 plus 9 plus 1 will give us 28. Remember your order of operations on this one. Again, for part B, f of 2 minus f of negative 2. What I'm going to do is I'm going to find f of 2 using my skeleton form. I'll use empty parentheses for my x's, and I fill in whatever I'm trying to evaluate at. 2 squared is 4. 4 times 2 is 8. Minus 3 times 2 is 6. Add 1. Let me see, 8 minus 6 is 2. 2 plus 1 is 3. Now I'm going to find f of negative 2. I'm going to use the same idea, the same skeleton form. That way I know what the function itself looks like. 2 times something squared minus 3 times something plus 1. Now fill in negative 2 in place of that something. Negative 2 squared is 4. 4 times 2 is still 8. But now a negative 3 times a negative 2 is a positive 6. 8 and 6 make 14, plus 1 makes 15. But we're not finished. Go back to the original problem. F of 2, that's in red, that's 3. Minus, because the problem is subtraction. F of negative 2, we replace that with 15. Now what's 3 minus 15? You know that that's negative 12. Our answer. Alright, let's see. what do we have now? Now we want to find f of x plus h. So I'm going to use the same idea. Skeleton form, f of x plus h inside the parentheses, and that's all squared, minus 3 times x plus h inside of parentheses. Anytime I evaluate, I always put my stuff inside of parentheses. Don't forget the plus 1. X plus h all squared. That is not x squared plus h squared. Make sure you multiply it all out. That's x plus h times x plus h. So x plus h all squared is x squared plus 2xh plus h squared. Then I multiply the negative 3 times x and a negative 3 times h. And don't forget your plus 1. And my last step, and this is it, we distribute the 2 into the first set of parentheses. We'll have 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1. Might be good for some of you to see where that x plus h all squared comes from. So we could write it here on the side. X plus h squared is x plus h times x plus h. And then we FOIL. X times x is x squared. X times h is xh. H times x is still xh. And h times h is h squared. The two xh's add together to give us the 2xh that we used in our parentheses. Now here's the good news about part D. Part D, we use what we already have. We already know f of x plus h. So I just take that bottom line from problem C. 2x squared plus 4x, ugly looking x, h, plus 2h squared, minus 3x, minus 3h, plus 1, and then I subtract the entire original function f of x. And because there's stuff going on, I use parentheses. So minus 2x squared minus 3x plus 1, all in parentheses, all of it divided by h. But check this out. The 2x squared at the beginning and the minus 2x squared in the parentheses, they cancel out. The minus 3x from the beginning and subtracting a negative 3x in the parentheses, they cancel out. A 1 minus a 1, they cancel out. Okay, now that everything's canceled out, we have 4xh plus 2h squared minus 3h all over h. So now everything in the numerator has an h, we could factor it out. So we have h times, in parentheses, 4x plus 2h minus 3. Ugly looking 3 again. But that's alright, because it's all divided by h. Our h's cancel out. And we're left with our final answer of 4x plus 2h minus 3. Alright, so the demand function for a specific product is given by Q equals negative 2p plus 360 units, where p is the price per unit. We're going to find the revenue function R of p. Remember that revenue is always price times quantity. So to find the revenue function, all we're going to do is multiply p times the Q value that's given, which is a minus 2p plus 360. Distribute that p, and you'll get negative 2p squared plus 360p, and that is our revenue function. So now we want to find the price that maximizes the revenue. As soon as we see that word maximize, we know we're looking for a vertex. So find the vertex formula, negative b over 2a. And the price is negative 360 divided by 2 times negative 2, which equals a negative 360 divided by negative 4, which is $90. Dollar signs are nice. We want to find the maximum revenue. So the maximum revenue is put the 90 that we found in the equation for revenue that we found also in part A. So that's negative 2 times 90 squared plus 360 times 90 which is negative 2 times 8100 plus 32,400, which equals 16,200. I have no idea why this is freaking out. It's weird, really weirding me out. Okay, moving on, part D. How many units must be produced to maximize the revenue? Well, the number of units is given by the function Q. So we put the 90 that we found for the price into the Q to get negative 2 times 90 plus 360 equals negative 180 plus 360, which is 180 units. Alright, so remember, units goes back to Q, revenue goes back to the revenue function, price, part B, on the last slide, that was the vertex formula. The half-life of cobalt-60 is 5 years. Now it's really tempting to think that this number 60 needs to be used somewhere. Let go of that. Remember, the half-life is 5 years, and we have a formula that says the K value is equal to the natural log of 2 all divided by half-life. So in this case, natural log of 2 divided by 5. If I find that on my calculator, natural log of 2, don't forget to close your parentheses, divide it by 5. We end up with, to 3 decimal places, 0.139. And that's all we need in order to write our model in this first part. Q of t equals Q sub 0 e to the negative 0.139. Let's make that 1 show up. And don't forget the variable t. That's where most people get it wrong. Okay, now we're going to use our model to predict to the nearest year. So we round to the nearest year. The time it takes for 1/3 of the sample to decay. Remember, if 1/3 decays, 2/3 remains. So 2/3 of whatever quantity we started with is equal to the quantity we started with times e to the negative 0.139 t. If we divide both sides by Q sub 0, we will have 2/3 equals e to the negative 0.139 t. And because this is an e, when we convert it to logarithm form, we'll have negative 0.139 t equals the natural log of 2/3, which gives us a t value that is the natural log of 2/3 divided by negative 0.139. And if you use your calculator for that, the natural log of 2 divided by 3, don't forget to close your parentheses, divided by negative 0.139, we'll get 2.917 or 3 years. Alright, so Harold will receive a $3,000 income tax refund. If he's going to receive a $3,000 income tax refund, his present value is $3,000. For a $40 fee, his accountant gives him an interest-free loan for the refund amount. The loan will be due in 4 weeks. So in 4 weeks, that's our time. But remember, since it's in weeks, and we always want time in years, that's 4 out of 52. So that's 1/13th if you want to use a simplified fraction. I do not suggest you use a decimal at this point. Go back to the problem. If Harold views the fee as simple interest, so the fee is simple interest, $40 fee. We know INT is $40. What is the simple interest rate of the loan? So we want to find the simple interest rate R. Looking at what we have, and this super important word simple, we use the appropriate formula and see that INT equals PV times R times T. In this case, that is 40 equals 3,000 times R, that's what we're looking for, times T. And you could use the 4 over 52. I chose to use the 1 over 13 because I happen to know how that reduces. Now, in order to solve this, I'm going to multiply both sides by 13. Let me see. When I multiply by 13 on the right, 13's cancel. And I have 3,000. Oh, I don't have 3,000 because I forgot to switch. I have 3,000 R. And when I multiply 40 times 13 on the left, I forgot my calculator. So that's a 0. And 4 times 13, 2652. So 520 equals a 3,000 R. To find the value of R, we're going to divide both sides by 3,000. And 520 divided by 3,000 is 0.17 and then a whole bunch of 3's. We want the interest rate. Because we want a rate, we want it in percentage. So the rate is 17.3%. Remember, if you have the decimal, move 2 places in order to get a percentage. As I'm reading through this problem, she has just received an inheritance worth $900,000. If she's received it, it is also a present value. She decides on an annuity. As soon as I know it's an annuity, I skip down a ways and I ask, what are we looking for? How much will the payments be? So if I'm looking for how much the payments will be, I use the annuity formula on the formula sheet that tells me how to find the payments. What is this? This is I over 1 minus 1 plus I to the negative n. So I need to find my I, which is the rate over m. I need to find my n, which is m times t. And those values are given to us up here in the problem. Let's see. Monthly payments for 15 years. So I know that my time is 15 years. I know that the annuity earns 5.2% interest. So I know my rate is 0.052. Remember to change it to a decimal. And I know that all of this is compounded monthly. Monthly everywhere we go here. So, monthly, my M value compounding 12 times per year. When I substitute everything in, my payment is equal to 900,000 times 0.052 over 12 divided by 1 minus parentheses 1 plus 0.052 over 12 to the power of negative 12 times 15. I'm going to enter all of this on my calculator exactly as it's typed. And when I do, I end up with the payment is $7,211.26. Why do I finish it with 26 cents? I go back here and I check, how do I want to round to the nearest cent? Alright, so we're going to solve this system of equations using Gauss-Jordan row reduction. But guess what? I don't care about this Gauss-Jordan row reduction. You can solve it just using regular old systems of equations. So what I would do is I would look at these two equations first and eliminate y. So let's do that. Since y already has the same number in front, 1, because, mathematicians are too lazy to write it, and they have opposite signs, all we have to do is take x plus y plus 6z equals 4. I'm getting used to a new pen, so go with it. X minus y plus 2z equals 2. Add the two equations together, so x plus x is 2x. Y minus y, they cancel out. 6z plus 2z will be 8z. And 4 plus 2 gives me 6. Now this equation, along with the bottom one, both have x and z. So what I'm going to do is I'm going to take this equation, 2x plus 8z equals 6, and I'm going to multiply the second equation, the third equation because it's on the bottom, times negative 2, because that way I'll have negative 2x minus 4z equals 0, and my x's cancel out. So 2x minus 2x cancels. 8z minus 4z is 4z. And 6 plus 0 is 6. When I divide by 4 and I simplify my fraction, I get z equals, make that a 4. Z equals 2/3. Now we could use our z equals 2/3 and put it into our bottom equation, and we can find x. So x plus 2 times 2/3 equals 0. X plus 4/3 equals 0. So x equals a negative 4/3. Let's write that over here. X equals negative 4/3. And then we can finish this off by finding our y value. And we could use either one. I'm going to use the top. I know that x is negative 4/3 plus y plus 6 times z. Remember, z is 2/3 equals 4. Negative 4/3 plus y plus, now 6 times 2 is 12, and 12 divided by 3 is 4. So I'll have a plus 4 equals 4. When I subtract 4 from both sides, these two cancel out. This will tell me that y is equal to a positive 4/3 when I add it to both sides. And I have my answers. You don't have to write the positive. That was just emphasizing it for the demonstration. Alright, you guys are really good at this one, but let's go over it anyway. A test requires that you answer first part A, and then, so we're going to multiply, either part B or part C. So I'm going to write that as A, and then B or C. And then means multiply, and or will give us a plus. And because we need to keep our order of operations correct, we have to put in the parentheses, or you could just do A times B, and then the or, do A and then C. Either way works out. I'm going to use the one on the left. So let's take a look. Part A consists of 7 true-false questions. So the number of options for each true-false question is 2, and there are 7 questions. We're going to multiply that by. Part B consists of 3 multiple-choice questions with 1 correct answer out of 5. 5 options for each question, 3 questions. Part C consists of 3 questions with 1 correct out of 4, so there's 4 possibilities for each answer, and there are 3 questions. I'm going to enter all of this into my calculator. Make sure you use powers. These are not combinations. These are anything else other than just powers. 2 to the 7th times parentheses 5 to the 3rd plus 4 to the 3rd. And if you have a calculator that shows you you're in the exponent, make sure you come out of the exponent before you go on to the next part. This is 24,192. I could probably make that 9 look better, or not, whichever. Again, we have problems here where you guys know what you're doing. So let's take a look. An author, 200 authors, 200 is my denominator. Is successful and new. Successful and new, so it's the 16 that overlaps. That's it. Don't make it harder than it needs to be. Again, an author, 200 authors, and is a new author. That's this whole column, so the total was 54. 54 over 200. You will be asked to either put these in 2 decimal places or reduce the fraction, but that's kind of secondary. As long as you can create the fraction, the rest of it you can work on after the rest of the exam is finished. Now we're going to look at a successful author. So successful authors, a total of 60. Is established. So only looking at successful authors, established is going to give me 44. An established author, so I'm looking only at established authors, the total is 146. Looking only at established authors, I want successful. Successful established authors are going to be the 44. And the difference between these last 2 problems is all in the denominator. What are we looking at as our total? In this problem, an unsuccessful author, so unsuccessful, that's this whole row, it's a total of 140. And out of those unsuccessful authors only, I want the new ones. The new ones that are unsuccessful will give me 38. Here we go, everybody's favorite, the marbles. Now, in the handout I gave you, and you should check it out, it's called Marbles and Authors, I think, on quiz for Chapter 7, Exam 3. I lead you through how many marbles are there total. Well, total for here we have 10 marbles. And she wants to grab 5. So in order to find our denominator, the number in our sample space, it will be the combinations of 10 marbles 5 at a time. This is never asked on the exam itself. It was on the formula sheet, but on the exam itself it's never asked, and I believe this is 252. So keep that in mind. This is always our denominator. Now we can get to what's actually being asked. None of the red ones. And I really should use a highlighter instead of a pen there. None of the red ones. So let's take a look at red. And then we'll take a look at all the others. Every single time you do this problem, you must account for all the marbles, all 10 of them. So how many reds do we have? We have 4. We want none of the red ones, so that's 0. And then, out of the other 6 marbles, we want 5. This will give us combinations of 4 objects taken 0 at a time. There's only one way to do that. Combinations of 6 items taken 5 at a time. There's 6 ways to do that. 1 times 6 is 6. And so if I want the probability as a fraction, I'm going to have 6 out of 252. And I can always reduce that in order to give my answer. I'm not going to do it here. Maybe I'll do this one, just so you could check your reduction. That's 1 over 42. My calculator is super handy. Now, a couple of things to look for. You must have this. You must have the combinations. The C is very important. If you just have the 4, 0, you're not going to get full credit for this problem. Make sure you do it correctly. Make sure you do it slowly. Okay, it's the same setup, and it's going to be the same setup on your exam for each question. It might not be the exact same as it is here, but she has 10 marbles. She wants 5. So this is my denominator for the probability, 252. Now, let's look at what's actually going on in this situation. At least. At least means, well, it depends on what it's at least of, huh? At least 1 means 1 or more. And in this situation, she has 2 white marbles. If she has 2 white marbles, that means 1 or 2. So first we calculate for 1 white marble, or for 2 white marbles. Since I'm not going to write in white, let's just make everything black here. So 1 white, the combinations of the 2 whites she has, taken 1 at a time. Oh, that looks ugly, I can't handle that. Let's fix that. The 2 whites she has, taken 1 at a time, and then the 8 others, she wants a total of 5, so she wants 4 more. Or, so we add 2 whites. The combinations of 2 whites, taken 2 at a time, and then, so multiply, the combinations of the 8 other marbles, and if I already have 2, I want 3 more, right? Because I want a total of 5. So the combinations of 2 marbles taken 1 at a time, there's 2. The combinations of 8 marbles taken 4 at a time. So let's use our calculator, and we're going to put in 8, and then go to probability, and choose the NCR, because it's combinations. We don't care about the order. And 8 NCR 4 is 70, plus 2 objects taken 2 at a time is 1, and NCR of 8, 3 will give us 56. 2 times 70 is 140, plus 56 equals 196. But remember, don't forget, find the probability as a fraction. Always write your answer as the fraction, the number of ways it can happen, divided by the total number of possibilities when you have 10 marbles and you want 5. And when we reduce this, we get 7/9. Don't worry, you won't have both at most and at least, I don't think. But let's make sure you're able to do it. At most 1 green. At most 1 green means at most. So 1 or less. In this case, and in any case actually, that's 0 green or 1 green. So let's do 0 green or 1 green. And we're going to put it all in black because it just shows up better. So how many green ones do we have? We have 3 green marbles. So the combinations of the 3 green we have and the 0 we want, and then the other 7 marbles we have, we want 5 of them. Or is going to tell us add 1 green. So the combinations of the 3 greens we have, we want 1. And then, so multiply the combinations of the 7 other marbles. We want 5 total. 1 of them's green, so 4 of them are not green. Combinations of 3 things taken 0 at a time is 1. The combinations of 7 things taken 5 at a time, well, let me see, 7 times 6, 7 times 3, that must be 21. Combinations of 3 things taken 1 at a time, that's 3. The combinations of 7 things taken 4 at a time is 35. 21 plus 105 equals 126. Don't forget the probability as a fraction. So this is 126 over our denominator of 252. That's all possible ways. Having 10 marbles, we can select 5. Alright, so now we're getting specific. 2 green ones and 1 of each of the other colors. So I'm going to write down all of the colors. Red, green, white, and purple. So 2 green ones and 1 of each of the other colors. So the combinations of the 4 red, we want 1 of them. And then the combinations of the 3 green ones, we want 2 of those. That's an ugly looking 3, but we'll take it. And then there are 2 white ones, but we only want 1. And then there's 1 purple one, and we want it. 4 things take 1, that's 4 ways. 3 things take 2, happens to be 3 ways. Combinations of 2 items taken 1 at a time is 2, and the combinations of 1 item taken 1 at a time is 1. 4 times 3 is 12, 12 times 2 is 24. Don't forget, as always, I'm going to remind you this because it was the biggest error, probably, on exam 3, probability as a fraction. So this is 24 out of the total of 252, which reduces to, wow. Try to hit the right buttons on your calculator so you don't get a crazy answer. 2 out of 21. Last problem on the review that we care about. She has all the red ones. All the red ones. So I'm going to look at red. And I'm going to look at others. So I know that there are 4 reds. And I want all 4. And then there are 6 other marbles. And I only want 1 of them. The combinations of 4 items taken 4 at a time is 1. The combinations of 6 items taken 1 at a time is 6. And 1 times 6 is 6. Again, broken record. Probability as a fraction. This is 6 out of 252. Which I believe was 1 out of 42. The same as answer A. Probability she has all the red ones. And the probability she has none of the red ones happens to be the exact same.